All right, welcome back to another one of Mr. A's famous grade 8 science classes. Thank you all for coming back in. We've already done attendance and I've already handed back your homework assignments. So I want to talk about now what we're going to be doing for the rest of the class. There are two major things we're going to be going over today. One is the experiment I promised you involving the slugs from the classroom aquarium to demonstrate osmosis. And the second thing you're going to be doing is I want you to break out of your regular groups, and one person from each of the groups is going to go around to each of the different groups. So by the end, you guys should all be with different people, and you're going to compare and contrast osmosis and diffusion. Now, we went over diffusion yesterday, and I will do another brief recap after you're done the first experiment of the day and before I get you into the second part. So don't worry about that. We'll get a little bit of study. Okay, so let's begin with the experiment that you're going to do for the next 15 minutes. You'll notice that there is one of the very lovely slugs from the classroom aquarium, a vial of salt, and a pitcher of water. Now, Mr. A would never condone killing an innocent creature, even in the name of science, but there is something about salting a slug that's a little bit too interesting to resist, and also a perfect demonstration of osmosis, because as we know from the three types of membrane, a slug has a fully permeable membrane. So when it gets that vial of salt dumped on it, the concentration difference between them is so vast that the water is literally, in layman's terms, sucked out of the cell. Okay, so let's begin. I want you guys to write a hypothesis down before you actually think, like, what do you think is going to happen to the slug, what's going to go down, and when everything is finished, I want you to dump that slug in water, really rinse him off, really get that salt off, because I do want to return all these slugs back to the classroom aquarium. They play a vital role in the aquarium's ecosystem. Okay. Pretend I just gave them 15 or so minutes to do the experiment. I would be walking around the classroom right now, making sure everybody's on task, on subject, and understanding what's going on, and also making sure nobody's killing anything or harming the slug any more than we're already doing in this experiment. Okay. Perfect, guys. So let us move on to the KWL charts that you have, because we do this every single day. These are the two things I want you to learn today. I want you to know how gases and liquids move in and out of a cell during the process of diffusion and osmosis, and I want you to understand the role cells, tissues, and organs play in plant and animal structure. So those are the two things that I want you to know. Now, while you have a minute, you should have been filling out what you already know and discussing it with your partners inside your groups. And then at the very end, I want you to write down what you've learned so that, that's for me, to recap what's going on. Okay, so quick review. What are the three types of membranes? Everybody pull out your P clickers that you have with you right now. I want you to answer that. You got 2 minutes. Pretend 2 minutes has gone by. I am very, very happy to see that we got the three right. We got permeable, semi-permeable, and selectively permeable. Okay, so what is a permeable membrane? That allows some things in and some things out. So you could think about it like we used the example. If the square is trying to get through the circle hole, it's not really going to fit, but the circle can always get through the circle hole, right? Just like in kindergarten back in the day. An impermeable membrane. I'm glad to see everybody got this one correct. Nothing's getting in, nothing's getting out, right? Absolutely. And then what is selectively permeable membrane? Exactly, it is. Some things can come in, some things can come out. That the cell wall and the structure gets to decide that. Okay, so the cell does control what moves in and what moves out of the cell. And remember, it controls not only the water elements, but also gas as well. We have oxygen, carbon dioxide, water here, different amino acids, carbohydrates, proteins. These are all selected by the cell wall, what gets in and what gets out in a selectively permeable membrane. Okay, so I do have a short 5-minute video to watch. This was on our Google Classrooms page, but as I can see, not all of you watched it. So I want to take a couple minutes here and let you guys go over this video, because I think it does a really good example of graphically demonstrating what's going on here. Assume they watched the video for 5 minutes. Okay, so particles moving in all directions bump into each other and eventually spread out evenly throughout the cell. That was the key word. They spread out evenly. Okay, this is another visual representation for those who didn't like the video. We're starting at high concentration, slowly starts to move over, more spread out until it's uniformly spread out. Now these are going to be the elements, the particles that are inside the cell. Okay, so now we're on to what's new, osmosis. So I want everybody right now to break up into their different groups and set up their own. You can do a Venn diagram. I honestly recommend that's the best way of doing it. We've gone over what Venn diagrams are, but if you have any other visual way or artistic way you want to represent it, that's perfectly fine. The point is to get the facts out. Now on the very next slide, I'm going to have the 3 facts that relate osmosis to diffusion. So before you begin, let's watch this short video right here, and then you're going to break out and use Google, use anything you want, YouTube, go to the different sites, find out the information you need, make sure it's valid. We've talked about validity on the internet. So I'll begin, start this video, and then I'm going to give you guys 15 minutes to go break up into your own jigsaw, come back together, and teach me something. Because you know Mr. A, he always needs to learn too. Okay, so that would be that, and then they would break up into their little groups, and then for the next 20 or so minutes of the remainder of class, they'd be going over osmosis contrasting with diffusion.